Hello class. In this short video, I'm gonna tell you about an application of the concept or the method of factorization. Remember that in this stage 2, we are talking about this method only. We wanna be skillful at this method in mathematics, factorization. And now that we know how to factorize, for example, this type of trinomial, this is a general trinomial of the second degree, if you remember the name. The concept of factorization can help us solve this type of equation, a quadratic equation, through that method, through the method of factorization. I'm going to teach you this technique first in this side in order so we can solve this problem. The following problem. The equation x squared plus ax plus b equals 0 has solutions x equals 2 and x equals 5. Find a and b. When you understand this, you're going to understand how we can solve this problem. So let's do it. We have a quadratic equation right here, guys. And as you may know by now, you can solve this equation through the general formula that you were probably taught in junior high, but we don't want to do that. We don't want to use that formula. I'm going to teach you another technique, the technique of factorization to solve this equation. And this technique relies on this fact, guys. This fact that I framed. What is this fact in mathematics? The fact is that if we have a product of two numbers, a times b, and that product is equal to 0, then what you should conclude is that either a equals 0 or b equals 0. So if the product of two numbers is equal to 0, at least one of them, either this one or the other, should be 0. Or also another possibility is that both need to be 0, but at least one. And that's a fact. Let's keep this just as a fact. We know this is true, and we're gonna use it to solve this equation in the following way. Let me put it in here again. X squared plus 5x plus 4 equals 0. This is the equation, and this is the trick, guys. This is the trick. What you want to do is factorize. If possible, you want to factorize this trinomial of second degree. This is a very simple factorization, and this is going to be such factorization. Okay, so this trinomial is factorized in this way, and I'm just going to continue writing the equation. If this is equal to this, and if this is equal to 0, then this is equal to 0. You see what I did? I just represented this trinomial in its factorized form. Okay, for what? For what? Because now I can apply this fact, guys. Remember, we accepted this as true. And it has the same shape as this. We have the product of two numbers being equal to 0. Can you see? This is one number and this is another number. This is one factor, this is another factor. This is the product of two factors, and that's being equal to 0. So therefore it has the same shape as this, and then we can conclude that either the first factor is 0, which is x plus 1, or the second factor must be 0. You see? And then I just keep going with my chain of reasoning. If this must be equal to 0 or this must be equal to 0, then if I isolate x from this equation, I'm going to get minus 1. Or if I isolate x from this equation, I'm going to get minus 4. And I'm done. I'm done. If you noticed, we have arrived at the solutions of this equation, guys. Okay, if you substitute either of these two numbers in here, this equation is going to be satisfied. For example, let's try minus 1. Okay, I'm going to get minus 1 to the square plus 5 times minus 1 plus 4 equals 0. And let's just do the arithmetic. I'm going to get 1 minus 5 plus 4 equals 0. And this is in fact true. 0 equals 0. So these two are the solutions, guys. These two are the solutions of this equation. And they were obtained by following this method, the method of factorization. I'm going to repeat what I did, like just verbally. What you did, guys, what I did is this. This is my equation. This is the trinomial that is being equal to 0. I'm going to factorize that trinomial, and I'm going to write down again the same equation as before, only in a factorized form. Then, since I have that the product of this times this is equal to 0, what I must conclude is that either the first factor, can you see, must be equal to 0, or the second factor must be equal to 0. And then once I have done this, I can realize that I have this very simple equation, also this one, and I just solve those equations. And I'm getting the solutions in that way. Now, the only other thing that I want you to realize is that these solutions, guys, these solutions can be quickly obtained out of these two binomials. If you notice, x equals minus 1, which is the opposite in sign to this number. You see? And x equals minus 4, that's the solution to this equation. And if you pay attention to this binomial, minus 4 is simply the opposite number. I mean the negative of this this term in here. So basically, guys, the solutions that you're gonna get at the end, these two solutions, will be the negative of the terms of these constant terms in these binomials. Okay, the negative, and that's it. That's how this method works. If you remain with some doubts, you can ask me in a moment, and we can actually work out another example in a moment, live. So let's see how this stuff helps me solve this equation, this problem. The problem says, once again, the equation x squared plus ax plus b equals 0 has solutions x equals 2 and x equals 5. And they want me to find a and b, these two numbers here that they're not giving me at this moment. Okay, so once again, guys, they are basically going backwards. They're giving me the solutions, and then they want me to find these two numbers. They're giving me the solutions to this equation. So if you paid attention to what I said here, the solutions, these two solutions to this equation, are the negatives of these two terms in this binomial, the negatives. So these two solutions must be the negatives of the same two binomials that multiplied would give me this, like in this way. Okay, these two are the negatives of these two terms. So what terms must I put in here? I need to put minus 2 and minus 5, because if I do that in this way, then this is a negative of this, and this is a negative of this, and the product of these two factors should give me the trinomial that I had in the first place. Now all that remains to be done is multiply or expand this product. So let's do it. X times x, x squared, x times minus 5, minus 5x, and then minus 2x, and then plus 10. Okay? And that's going to be equal to x squared plus ax plus b. And then let's simplify a little bit. you must have this, and then you must realize that if this should be equal to this, then we can clearly see that A must be minus 7 and that B must be plus 10 according to the form that these two trinomials have. Why? Because A is the number that multiplies x, and the number that multiplies x in here is minus 7, and B is the constant term, which is 10. So I'm done. A must be minus 7 and B must be 10. So that's how this problem is solved, by recurring or by making use of this fact. I don't know if that was clear to you guys. If it wasn't that clear, we can work it out again in class. No problem. I can tell you how to do this in more detail. Okay, thank you guys.